In this video, we're going to go through an example of a related regs problem. In the problem reads, a police car is located 30 feet to the side of a straight road. A red car is driving along the road in the direction of a police car, and it is 200 feet up the road from the location of the police car. The police radar reads that the distance between the police car and the red car is decreasing at a rate of 70 feet per second. How fast is the red car actually traveling along the road? So here's our picture. Here's our road. Here's the red car. I'll label that with a red dot. Now the problem states that the police car is 30 feet off the side of a straight road. So the police car, I'll label that blue. This is going to be 30 feet off the side of the road. And so we've got a triangle here, and it's going to be a right triangle. Now, if we label this side, let's call this X, Y, and Z. The problem states when the police officer reads the radar, the car is 200 feet up the road. The problem also says that the police radar reads the distance between the police car and the red car, which is the Z, is decreasing at a rate of 70 feet per second. So the change of Z, that distance with respect to time, is negative 70 feet per second. So let's find out what the distance is for Z when the car is 200 feet away. The square root of 200 squared plus 30 squared, which would be approximately 202.2374842. So when the car is 200 feet up the road from the police officer, the direct distance from the red car to the police officer is 202.237 feet. So what we need to find is the actual rate of the car on the road. How fast is that car actually driving on the road? So we need to find dx dt. That's what we're looking for. This formula, x squared plus y squared is equal to z squared. Now, x is changing with respect to time, and z is changing with respect to time, but the distance that the cop is sitting off the road, that 30 feet, that distance for y, is not changing. So I can plug that in as a constant. Now, we're going to take the derivative. The derivative of x squared plus 30 squared is equal to z squared. So I'm going to take the derivative of x squared first. That's 2x. Now, since x is changing with respect to time, I have to use the chain rule and multiply by dx dt. When I take the derivative of 30 squared, that's a constant, so that's going to be 0. And then when I take the derivative of z squared, that's also changing with respect to time. So I'm going to write this as 2z, and then I have to use the chain rule, dz dt. Now, when I clean up this equation, I don't need the 0 in there anymore, and I can divide both sides by 2. So what I have is x dx dt is equal to z dz dt. Now, I know that we are trying to find the change in x with respect to t. That's the change in the distance over the road. That's the guy's speed on the actual road. Now, we're given that dz dt, the change in the hypotenuse, the direct distance to the police car, is negative 70 feet per second. So I'm going to plug that in for dz dt. I also know that the distance at the time that we're looking for that speed is 200. So I'm going to plug all this in. So I have 200 times dx dt is equal to, now when the distance on the road is 200, using the Pythagorean theorem, we got that the value of z was 202.2374842. So I'm going to plug that in for z, and we know that dz dt is negative 70. So now I can solve for dx dt. When I solve for dx dt, I'm going to get negative 70.78311947. Now, if you want to answer using velocity, this would be the velocity. If you want to answer using the speed, remember, speed has no direction. It's just how fast the car is going, not the direction. So for the speed, we would answer it as 70.78311947, and that would be feet per second. Same thing for this one. This is feet per second. Just remember, depending on what the question is asking for, with the velocity, you would answer it with a negative. For speed, you would answer it without the negative.